Hey guys, tonight we're going to a place you've probably never visited unless your soul took a wrong turn during a dream and accidentally drifted 5 million light years from Earth. You find yourself coasting through the stars in the direction of something big, something beautiful, something hungry. The Andromeda Galaxy is stretched out before you like a glittering spiral chandelier, glowing in soft blues and purples, the shape of a hurricane frozen in time. It's massive, really massive, twice the size of the Milky Way, with perhaps 1 trillion stars. And if you look closely, you'll notice it's pulling some shady cosmic moves on the little guys around it. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I'd love it if you left a comment with your current location and what time it is where you are. I find that oddly fascinating. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start your drift at the outermost edges of Andromeda, where the stars get sparse and quiet. The gravitational tug is subtle, but insistent, like the ocean calling back its tide. You're coasting toward a feast that's already underway. Though the main course is still a few billion years off, beneath you, small satellite galaxies orbit like moths around a lantern. They don't yet know they're doomed, or maybe they do, and just don't care anymore. Historians of the cosmos still argue whether Andromeda is a natural cannibal or just a victim of circumstance. After all, when you're the biggest gravitational boss in the room, things tend to fall into your lap or your core. Over the past several billion years, Andromeda has quietly consumed at least a dozen smaller galaxies. That might sound rude, but in the universe, it's just what galaxies do to survive. And Andromeda's survival instinct is strong. You feel the first shimmer of distortion ripple through you. It's the light from stars that no longer exist. Ghosts of ancient suns devoured long ago. Some of them belong to galaxies with names that sound like whispered numbers. Andromeda I, 2, 3. Each one a once independent system, now little more than a stream of scattered starlight, curling inward like smoke from a candle just blown out. In one of those now extinct galaxies, once upon a cosmic time, alien civilizations might have looked up at their sky and wondered why it was slowly unraveling. Their night might have changed subtly new stars, odd trails across the firmament, like cracks in glass. Then, gravity did what it always does. It pulled, it stretched, and eventually, it swallowed beneath you. The stars twinkle with that cold indifference only galaxies can master. You pass through a zone where scientists believe a recent merger took place. There's no plaque, no sign, no cosmic museum gift shop, just a subtle thickening of stardust, a faint trail of redder stars that were likely yanked out of orbit and absorbed into Andromeda's vast arms. It's like looking at tree rings but with light. One mainstream astronomical fact: Andromeda is on a direct collision course with our own galaxy, the Milky Way. The math isn't complicated. It's heading straight for us at about 110 kilometers per second. That's about 250 miles per hour. So yes, technically, space is trying to give you a high-speed hug. You probably won't survive this, but don't worry. It won't happen for another 4 billion years. You've got time to finish your tea. Now, something quirky. At the very edge of Andromeda's halo, astronomers once discovered what they thought might be a satellite galaxy. Turned out, it was actually a clump of stars left over from a previous merger. Like cosmic breadcrumbs. They called it a ghost stream. You hover through it now. It doesn't glow. Exactly, it hums. You imagine the stars whispering secrets to one another. Secrets only the very old and very consumed might know. Your surroundings get busier. The density of stars increases. It's like swimming from a quiet lagoon into open ocean, where the currents move with intent. you realize you're not alone. Small galaxies drift nearby, awkwardly, as if trying to decide whether to run or surrender. They can't escape Andromeda's gravity, reaches out with invisible fingers, slowly reeling them in. You pass a warped little thing, its spiral arms bent, like someone twisted a paper plate. That's Andromeda Visitorhose, or at least what's left of it. A dim dwarf galaxy, low in brightness but high in drama. Its stars are currently being stripped, one by one, to become part of something larger. It's not a fast process. Galaxies eat politely. It can take billions of years to chew. Still drifting inward, you feel the light begin to press in thicker now, tinged with shades of blue and silver. That's Andromeda's dominant color palette, the cool light of young stars. New stars are still being born here, sparked from the gas stolen during mergers. It's the universe's way of saying, thanks for the meal. Now, here's something new. You might be wondering what this all means. Why does a galaxy eat its neighbors? Are we just in some massive game of gravitational Pac-Man? Well, kind of, yeah. But the bigger story is this. Galactic cannibalism shapes the universe. Every time Andromeda absorbs a smaller galaxy, it grows not just in size but in character. Its shape changes, its spin shifts, its heart, its core becomes denser. One day, it will meet the Milky Way, and the final phase of this long meal will begin. But for now, you float on toward the next bite. You're still gliding, but now the scenery thickens. Around you swirls a haze of stars arranged in soft, tangled loops, stellar graffiti painted by the slow-motion violence of gravity. You've arrived near one of Andromeda's strangest victims, M32. On the surface, it's a simple dwarf elliptical galaxy, small and unassuming, shaped like a puffball of stars. But the more you study it, the more it seems off. M32 orbits unusually close to Andromeda, so close that it's basically getting a gravitational wedgie. Andromeda's mighty pull has squeezed and stretched M32, possibly even stripped away its outer stars in a galactic version of peeling a grape. What's left is a compact core, so dense with stars. They bump elbows. You float above it now, gazing down at what may be the remains of a much larger spiral galaxy, one that's had its limbs torn off in a cosmic brawl. Astronomers still argue whether M32 is a surviving remnant or a restructured corpse. Some believe it was once a glorious spiral galaxy, complete with arms and all the trimmings, until Andromeda came along, tore off those arms, ate most of its gas, and left behind just this compact stellar nugget. If true, M32 is not a neighbor, it's a former feast, its bones polished by time. One mainstream historical fact, M32 was the first elliptical galaxy ever discovered, way back in the 18th century, by the French astronomer Guillaume Le Gentil. He spotted it while trying unsuccessfully to observe the transit of Venus. As you hover here, you wonder if he had any idea that the little blob he marked on his notes was actually the battered remnant of a once majestic galaxy. Now for the weird part, some fringe theories suggest that M32 might be the gravitational culprit behind certain star streams that appear to arc oddly across Andromeda. Imagine tossing a rock into a pool and watching the ripples twist not evenly, but skewed, distorted. That's what Andromeda's halo looks like in some places. And some astronomers blame M32. It's like the ghost of a buffet past still stirring the soup. The space around M32 isn't empty. You drift through a region teeming with rogue stars, ones that no longer belong to either Andromeda or M32. They were ripped from their homes during the great gravitational feast and now float untethered, orphans of galactic violence. Their paths are chaotic. Some loop lazily through the outskirts. Others are on a slow journey out into intergalactic space, possibly never to be caught again. You pass near one of these wanderers, a red giant with a lonely glow. Its surface trembles gently with internal storms, and you imagine it whispering tales of the day. It was pulled from the spiral arm of its galaxy, spun into a whirlpool, and flung like a leaf in wind. Stars don't scream, but if they could, this one might have howled. Another scholarly debate, whether M32's influence might actually be ongoing. Some simulations suggest it could still be nibbling away at Andromeda's outer halo, stealing stars in return, a two-way street of cosmic consumption. Galaxies, like bad roommates, often borrow things without asking, sometimes entire solar systems. From your perch, you can see how close M32 orbits to Andromeda's core. It's like a bee buzzing too close to a bonfire. One wrong move and it could plunge inward, becoming the next snack in a very long meal. You marvel at the balance. These two dance around each other in slow, looping arcs, each orbit taking hundreds of millions of years. Time moves differently here. Slower, heavier. You float downward now, deeper into the gravitational well that tugs at M32. Your view widens. Below, you glimpse the broader galactic disk of Andromeda, immense and spinning, glowing in soft starlight. It's not flat. No galaxy is truly flat. There's a gentle curve to it, like a frisbee dipped in syrup. And within that frisbee, the story of M32 is etched in scarce, faint streaks where its stars once were, warps in Andromeda's arms that betray an impact long ago. You realize something. This isn't just one galaxy eating another. It's a relationship, toxic perhaps, but intimate. M32 has changed Andromeda forever. The meal has shaped the eater. As you coast higher again, away from M32's dense star cluster, a question emerges like a ripple through your mind. What does it mean to lose your shape, your gas, your very stars, and still be a galaxy? M32 might be a survivor or a ghost. Either way, it's still here, still orbiting, still refusing to disappear. You leave it behind, gently now, like tiptoeing away from someone fast asleep. But even as the stars of M32 dim behind you, its story clings to you, a reminder that galaxies, like people, carry their scars. They wear their history in their shape. And as you drift on, deeper into Andromeda's buffet line, you can't help but wonder how many more M32s lie ahead, how many stories carved into starlight, waiting to be read. You're drifting again this time, toward another shadowed companion of Andromeda, though to call it a companion might be overly polite. It's M110, and from a distance, it looks like just another dwarf elliptical galaxy, tagging along obediently behind its bigger host. But as you approach, the mood changes. There's something different here. Less of a companion vibe, more of a ghost story. M110 is a soft blur of stars with a lopsided glow, like it's been caught in the act of trying to escape but didn't get far. You ease into its orbit and feel the tension. Something about the way the stars flicker unevenly, the way the light thins near the edges, suggests that this galaxy is in the process of falling apart, or perhaps already has. Astronomers believe M110 is currently being digested. Unlike M32, which may have already been chewed and reshaped, M110 seems to be in that awkward middle phase, where it's lost just enough of itself to feel the pull, but not enough to vanish entirely. You could call it galactic purgatory. Historians still argue whether M110's fate is sealed or if it might wobble away, like a stubborn crumb stuck on a black hole's lip. You drift through a strange halo of stripped stars surrounding M110. These stars no longer orbit their original galaxy. They're stretched out into a faint arc, like beads on an unraveling necklace. To the untrained eye, it might look like nothing. To you, now attuned to galactic clues, it's unmistakable. A signature. This is what cosmic hunger looks like, not fast, not loud, but inevitable. One mainstream fact: M110 is the second brightest satellite galaxy of Andromeda after M32, but brightness doesn't equal stability. Its core still holds together, dense with ancient stars, but the edges flaking, fading, gone. You pass a swirl where dark matter and gas used to cradle starbirth. Now it's cold, silent, like a nursery after the kids have grown and gone. The odd thing, your quirky fringe tidbit for the night, is that M110 has its own system of star clusters. That's right. Even though it's the sidekick of a galaxy that's actively trying to digest it, M110 has satellites of its own. Little globular clusters still circle it, unaware or uncaring that their host is slowly dissolving into the greater glow of Andromeda. It's like showing up to a party and realizing your host is being eaten by the house. Some simulations suggest that M110's outer stars are already on borrowed time, caught in what's called a tidal tail. You coast through one now, a lazy stream of starlight that arcs back toward Andromeda like a cosmic breadcrumb trail. Each star is a refugee, tossed into the void by tidal forces and left to drift between worlds. You watch as one particularly bright star tumbles slowly end over end, its light tinged slightly yellow, its surface spotted and cracked like an old porcelain lamp. It's alone, but not lonely, not here. Everything in this part of the universe moves together, drawn forward by gravity's patient hunger. The scholarly debate gets more interesting here. Some believe that M110 might have once orbited in the opposite direction. If true, it could explain the asymmetry in Andromeda's halo, like a tide that broke wrong. You imagine it, long ago, drifting against the stream, resisting Andromeda's spin, a tiny galaxy saying no to the whirlpool. For a while, it might have even made it, but here it is now glowing dimly, falling inward. You skim across M110's core, and it feels soft. Not literally, of course, but the gravitational field here is calmer than expected, like the heart of the galaxy has given up fighting. The stars are old, most over 10 billion years. They twinkle with a gentle rhythm, like the breathing of something ancient and tired. And in this tiredness, you feel something strangely comforting. 110 isn't going out with a bang. It's not exploding. It's not colliding in fury. It's fading, slowly, like a candle on its last hour. And in that slow fade, it's giving itself to Andromeda, one star at a time. Not a tragedy, a transformation. As you rise higher, you glance back one last time. M110's lopsided shape is more visible from this angle, its elongation in the direction of Andromeda, a silent surrender. You imagine it whispering, "Take me, but let me leave a trace." And it will, long after M110 disappears. Its stars will remain in Andromeda's halo. Its clusters will be studied, catalogued, maybe even visited by whoever or whatever is floating through the cosmos a few billion years from now. For now, though, you leave it to its quiet fate. The stars around you thin again, and Andromeda looms larger. The meal continues. The space around you has changed again. It's less like floating and more like following a trail now. A shimmering, silver thread stretches across the dark, a river of stars arcing gently through space. You follow it like a fish swimming upstream, letting it guide you. These aren't just pretty lights. They're evidence of something once whole, now unspooled across Andromeda's vast gravitational net. You're drifting along a stellar stream, a cosmic breadcrumb trail left behind when a galaxy gets torn apart. You're not looking at a galaxy anymore. You're looking at its ghost. The stars around you were once tightly bound, cozy neighbors orbiting a common center. Now they drift in graceful curves and loose spirals, like confetti caught in a slow breeze. Andromeda has dozens of these streams, each one a story, each one a galactic obituary written in light. They stretch thousands of light years, wrapping around Andromeda like threads around a spool. Some are still connected to faint dwarf galaxies being unraveled. Others are all that's left, hazy remnants with no visible core, no home to return to. One mainstream fact: stellar streams are used by astronomers to map the distribution of dark matter. Since stars in a stream respond to the gravitational shape of the galaxy, their paths reveal where invisible mass is hiding. You're not just floating through starlight, you're floating through a living map of Andromeda's bones. You take a deep breath, metaphorically, of course, and sink deeper into the stream. Around you, the stars shimmer faintly, tinted in soft oranges and deep reds. Older stars, mostly red giants with creaky cores, no longer hot-blooded newborns, but reliable elders. There's a kind of wisdom to their arrangement, like they're still trying to orbit something, even if it no longer exists. Historians still debate how many of these streams belong to known galaxies. Some match up nicely with surviving dwarfs, like Andromeda I and Andromeda X. Others, though, are mysteries, disembodied arms with no body. Some even loop behind Andromeda, visible only in infrared scans or through gravitational lensing. It's like walking into a forest and finding a dozen shoes with no people in them. You pass a curious sight, a pair of stars twinned in orbit, spinning slowly around each other like dancers unwilling to part. Binary stars are not uncommon, but here, in the aftermath of a shredded galaxy, their persistence feels poetic. Maybe they were pulled from a globular cluster together. Maybe they just found each other amid the chaos. Either way, they're still holding on. A fringe theory emerges in your thoughts. Some researchers propose that these streams may contain rogue planets, worlds no longer bound to any sun, cast loose in the merger. Picture that. Entire Earth-like planets, drifting frozen through the dark, orbiting nothing. It's the loneliest image imaginable, and yet oddly peaceful. You approach a thicker section of the stream, almost like a traffic jam of stars. Here, simulations suggest, is where the parent galaxy began its final disintegration. The stream's width increases. Its stars wobble in wider arcs. You can almost see the unraveling in motion, like the slow unspooling of thread from a sweater, except the sweater was a galaxy, and the hands pulling it apart were made of gravity. Somewhere nearby, a faint glow catches your eye. It's a globular cluster, a tight sphere of old stars, unusually intact. Perhaps it once belonged to the lost galaxy you're tracing. Now it spins slowly in place, a relic clinging to identity. You dip into it for a moment. The stars here are crowded, like a packed subway car. There's tension in their movements, like they remember when they were part of something bigger. You can't help but smile at the thought that even as galaxies die, parts of them persist. Clusters like this one survive the fall. They become fossils in orbit, studied by future species as hints to a past no one remembers. The debate continues whether these streams were always destined to form, or if some are accidents, unique only to Andromeda's gravitational weirdness. Maybe our own Milky Way will look like this one day, trailing light across the sky like cosmic hair in the wind. You rise higher, breaking from the stream for a broader view. Beneath you, it curves away into Andromeda's distant arm, thinning into nothing. You feel a twinge of loss. Not your own, but the galaxy's. Each of these streams was a neighbor, a guest, a sibling. Now they are threads in a tapestry no one wove on purpose. As you turn, more streams come into view, some nearly invisible, others bright and proud. They twist and twine around Andromeda like the remnants of past meals it hasn't fully digested. There's no rush. In space, digestion takes eons, but the evidence is here. If you know how to look, you're surrounded by it, and so you glide forward, away from this trail of memory, toward a darker region where something deeper and much hungrier waits. the light begins to change again. It's not the stars this time. It's the way space itself seems to bend. There's a density here, an invisible pressure, like you've entered the lungs of something ancient and alive. Below you, deep within Andromeda's core, churns a presence you can't see, but absolutely feel. You're entering the domain of the supermassive black hole. This one isn't just any black hole. It's huge, about 100 million times the mass of our sun. It sits right at Andromeda's center, like a patient spider at the heart of a galactic web. Everything orbits it. Everything bows to it. Stars, gas, dark matter. Even time seems to lean inward here. It doesn't scream. It doesn't roar. It simply exists in absolute silence. The stars closest to it spin fast, whipped around like sparks on a grinding wheel. You ease closer, just to the edge of safety, or what would be considered safe if you were anything other than an incorporeal observer on a bedtime voyage. Here's a mainstream fact. Almost every major galaxy is believed to harbor a supermassive black hole at its core. Andromeda's is no exception. It's officially named NGC 224's central black hole, though that doesn't exactly roll off the tongue. Some call it a sleeping monster, because despite its size, it's currently quiet, not consuming, not flaring, just waiting. But it hasn't always been so. You pass through a region dense with X-ray echoes, like the cooling walls of an ancient furnace. Astronomers have found signs that Andromeda's black hole used to be active, a quasar-level beast that once spat jets of radiation across space. Imagine a flashlight so powerful it scorches everything it touches. Now imagine that flashlight aimed at you, but don't worry, it's off now, sleeping. For now, historians still argue whether Andromeda's black hole is growing fast enough to keep up with the galaxy itself. Some models say it's too small for a galaxy this big. Others think that's because Andromeda doesn't feed it often. It's picky. You might say selective in its snacking, but when it does eat well, entire stars go missing. A quirky tidbit for you. In 2005, astronomers using the Hubble Space Telescope noticed something odd at the very core of Andromeda, a double nucleus. Two bright star clusters, extremely close together, circling the black hole like twin sentries. This isn't normal. The leading theory, one of them is the actual center, while the other is a cluster of stars caught in a wild orbit around the hole. From your vantage point now, you can see the distortion, a subtle swirl in the fabric of space where those clusters dance. You move closer, and the stars thin. The gravitational forces here are intense, not just downward, but sideways, inward, backward, like being in a whirlpool where every direction leads down. Some of the stars here are doomed. They're on decay orbits, slowly spiraling toward the event horizon. One day, they'll vanish, their light stretched to invisibility, their mass donated to the black hole's endless hunger. You spot one such star now, a blue giant with a wobble in its path. Every orbit it gets closer. One day, it'll cross the point of no return. The black hole won't roar. It won't gloat. It'll just blink, and the star will be gone. Not even light escapes. There's a kind of dark elegance here. You might expect terror, but instead you feel awe. There's no malice in a black hole. It's not evil. It's just gravity turned up to 11. And Andromeda's is content for now to let the galaxy swirl around it like cream in a cosmic coffee cup. The scholars still don't agree on whether this black hole formed at the very beginning of Andromeda's life or if it grew later, fed by mergers and meals. There are theories that Andromeda devoured another black hole during a past collision, that there's a secondary one drifting somewhere deep in the core, hidden, waiting to fuse. If so, then one day, a gravitational wave will ripple through this galaxy like a bass drop in the fabric of reality itself. You drift back from the core, the light returning as you escape the grip of the black hole. Around you, stars resume their calmer orbits. The chaos recedes, but you carry with you the weight of what lies beneath. It's not loud, it's not flashy, but it's there, shaping everything. And somewhere, far above this sleeping giant, galaxies still spiral closer. Someday, they'll arrive, and maybe then the monster will wake. You rise again through Andromeda's dense midsection, letting the chaos of the core fade behind you like a dream just barely remembered. The stars begin to spread out, cooler now, more orderly, as if you've passed through the heart of a storm and emerged into calm skies. But that calm is deceptive because ahead of you floats another galaxy, much smaller than Andromeda, but not yet eaten, not yet. You found Triangulum, also known as M33, Andromeda's largest remaining neighbor, and possibly its next course. From a distance, Triangulum looks delicate. It's a face-on spiral galaxy, bright and flat, like a silver coin left to spin on the table of space. You approach slowly, drifting through the tenuous gravitational bridge that connects it to Andromeda, a filament of dark matter, gas, and possibility. The two galaxies aren't just neighbors. They're connected by an invisible leash, and the tension on that leash is growing. One mainstream fact: Triangulum is the third largest galaxy in our local group, after Andromeda and the Milky Way. It's roughly 60 light years across, about half the size of our home, but unlike Andromeda's tightly packed elegance, Triangulum is looser, messier. Its spiral arms are clumpy with star-forming regions that glow bright blue. It's a younger sibling trying to prove something. As you coast toward it, you notice something subtle. Triangulum is wobbling, not spinning smoothly, but twitching slightly, like it's uncertain of its balance. This isn't just a cute personality quirk, it's a gravitational symptom. Historians still argue whether this wobble is caused by an ancient flyby with Andromeda, a close encounter that didn't result in collision, but shook Triangulum like a tuning fork. There are models that suggest the two galaxies may have orbited each other in the past. Imagine that, galaxies locked in a gravitational tango, drawing close, then drifting apart again over billions of years. Now, as you hover between them, the metaphorical air feels heavy. The future is pulling, literally. One fringe theory suggests Triangulum may not survive its next close pass, not whole. Anyway, some believe that in about 5 billion years, Andromeda will finally make its move, drawing Triangulum in and peeling away its stars, one layer at a time. The leftovers might be flung into deep space or woven into Andromeda's spiral arms. Either way, Triangulum's days as an independent galaxy may be numbered. You drift over one of Triangulum's spiral arms now. The difference is striking. After the dense, ancient starlight of Andromeda, this place feels younger, more alive. There are star nurseries everywhere, thick clouds of gas glowing pink and violet, birthing clusters of newborn suns. The largest of these is NGC 604, a massive star-forming region, so bright it could outshine whole galaxies. You pause there for a moment, watching the swirl of gas collapse into stars like glitter forming into snowflakes. And then it hits you. Triangulum is still growing. Even as it risks being consumed, it's still trying. There's something oddly human about that. A little farther out, you catch a glimpse of one of Triangulum's satellite star clusters being tugged ever so slightly toward Andromeda. It's not fast, it's not violent, but it's real. Gravity doesn't need to shout, it just waits. And when the moment is right, it pulls. You rise again, higher now, looking down on the space between the two galaxies. It's vast, over 750 light years, and yet they feel close. You realize that in cosmic terms, they're practically nose to nose. There's no escaping each other, whether they merge gently or tear each other apart. Their fates are now entwined. The scholarly debate shifts again. Some simulations suggest that when Andromeda finally collides with the Milky Way, Triangulum might crash into the mess, too, either adding to the chaos or altering the shape of the final galaxy that forms. Others say Triangulum might get flung out entirely, like a third wheel tossed during a slow-motion collision. That would be dramatic and possibly beautiful. From up here, though, it all looks calm. The stars don't panic. The galaxies don't scream. They just keep spinning. The bridge between Andromeda and Triangulum continues to stretch. And you, drifting like a feather between giants, can't help but wonder, if galaxies have destinies, what is Triangulum's? You turn your gaze back toward Andromeda. Its spiral arms glisten in the far distance, massive and still, waiting. It's patient. This galaxy, it has devoured dozens before. Triangulum is just next, but not tonight. Tonight, they're both still free. You leave Triangulum behind like a childhood friend who hasn't yet learned what fate has in store. Ahead of you, Andromeda sprawls wide again, its great spiral arms curling inward like the slow unfurling of a giant fern. But this time, you're not diving into its glow. You're drifting above it into the sparse outer regions where the starlight dims and something stranger begins to take shape. You've entered the halo, not the glowing one above an angel's head, though. Now that you think about it, there's a certain elegance here that feels holy. Andromeda's halo is vast, nearly invisible to the naked eye, but unmistakably present. It stretches over 1,000,000 light-years across twice the width of the visible galaxy, and it's full of clues. Clues about Andromeda's past conquests, its secret meals, and the structure of the cosmos itself. You glide through this halo now, a region of ancient starlight, diffuse gas, and something you can't quite see but absolutely feel, dark matter. Scientists estimate that over 90% of Andromeda's mass is dark matter, most of it lurking out here in the halo. It doesn't glow, it doesn't clump, but it warps gravity itself. You float past stars that orbit nothing, held in place by forces you can't see, like moths circling a flame that hasn't been lit. Here's one mainstream fact. The stellar halo of Andromeda is peppered with shells, curved loops of stars that look like ripples on a pond. These aren't natural formations. They're scars, remnants of galaxies that got too close, were swallowed, and left behind rings of stars in their final orbits. You coast over one now, a half-formed arc shimmering faintly, like the outline of a ghost's jawbone. Historians still argue whether these shells are from one massive merger or the messy leftovers of many smaller ones. The shape of the halo doesn't quite match Andromeda's inner symmetry. It's lopsided, warped as if something big hit it long ago, and it never fully recovered. You can almost picture the impact, like a snowball crashing into a pile of leaves, sending trails flying in every direction. Suddenly, something flickers ahead, a twisting thread of stars arcing in a tight loop. It's a tidal loop, another type of stellar stream. But this one curls around in a full 360-degree spiral. The stars here aren't just drifting. They're trapped, caught in orbits that have no center anymore. You pass a clump of them now, spinning slowly like forgotten dancers still moving after the music stopped. A quirky tidbit for your journey. There's a strange, cold cloud drifting through Andromeda's halo that emits almost no light, but was detected through its gravitational lensing effect. It's not clear what it is. Some suggest it's a dark matter-dominated remnant of a galaxy that Andromeda tried to digest but choked on, the ghost of a meal that refused to be swallowed. You circle this region slowly, watching faint star clusters drift like pollen on a cosmic breeze. Many of them have no clear origin. They don't match the motion of Andromeda's disk. Some even move backwards, retrograde motion, a sure sign they didn't form here. They were caught, their allegiance forced, not chosen. If galaxies had immigration offices, this would be their waiting room. Another open debate lingers in your mind, whether our own Milky Way has a halo this complex. Observations suggest it does, but Andromeda's is easier to study because, ironically, we're not inside it. We can see it whole. Ours, we're too close, too embedded in the disk to see the full sprawl of our own galactic ghost trails. It's like trying to draw your own face without a mirror. You turn gently now, letting the glow of the galactic disk return to view beneath you. From up here, Andromeda looks like a living fossil. It's bright, spinning center surrounded by a soft cloud of memory. Every shell, every loop, every faint curve of light out here is a story. Not one written in books, but in physics, in motion, and all of it points to one conclusion. Andromeda didn't form in peace. It grew by taking, by pulling, by swallowing. It's not just a galaxy, it's an archive of conquests. The halo is its library, and the books here don't end. You drift backward, letting your momentum carry you toward the edge of this unseen realm. The stars grow sparser, the darkness gets darker, but you're not scared. There's a kind of peace here, a quiet confidence in the way Andromeda holds onto its scars, not as shame, but as shape. And just before you leave the halo, you spot one final thing, a single, isolated star, dim, red, slow-moving, alone. It could be the last remnant of a galaxy long since erased, or maybe a new arrival, not yet claimed. You wonder, will someone find it one day, trace its motion, and learn its story? Or will it drift forever, unseen? You blink, and it's gone. Andromeda's halo closes behind you like a sigh. You're heading back toward the disk of Andromeda now, the warm light returning like a blanket pulled over your shoulders. The grand spiral arms extend beneath you, wrapped with rivers of stars, gas, and memory, but your gaze drifts ahead, not down, because far beyond the edge of this galaxy, another familiar shape waits, one you know very well. You're looking at home. There it is, the Milky Way, stretched across the dark like a band of misty light. It doesn't look so tough from here, just another spiral among billions, but between these two giants, Andromeda and the Milky Way, there is a slow, inescapable gravity pulling them together. You're watching it happen. Right now, they're about 5 million light-years apart, which sounds like a lot. But when galaxies get moving, even that much space starts to feel small. The Andromeda Galaxy is heading straight for the Milky Way at a speed of about 110 kilometers per second. That's fast enough to cross the Earth in just over 2 minutes. You might want to brace yourself in about 4 billion years. They're going to collide. Mainstream fact. This isn't speculation. It's math. Based on redshift and blueshift measurements, astronomers have mapped the exact path of Andromeda's approach. It's not a maybe, it's a date, albeit one scheduled for long after our sun has bloated into a red giant and Earth, well, may no longer be in the mood for sunsets. But don't panic. Galactic collisions aren't like car crashes. They're more like two clouds passing through each other. Despite the billions of stars involved, the space between them is so vast that very few actual stars will touch. So no fireballs, no Michael Bay explosions. Instead, it'll be a graceful chaos, a reshuffling of matter on an unfathomable scale. As you drift between these two colossal galaxies, you feel the pull, not metaphorical, the actual pull of gravity, stretching across millions of light years. This space between them isn't empty. It's filled with dark matter, dust, rogue stars, even wandering black holes. And you're right in the middle of it, hovering between future and past. There's another curious fact. The Milky Way and Andromeda are tilted toward each other in just the right way to produce something spectacular when they merge. Astronomers predict that, after the first pass, the two galaxies will swing back and forth like dancers slowly pulling into a final embrace. It won't be a quick kiss. It'll take billions of years. Stars will be flung into wild orbits. Spiral arms will tear. New shapes will form. And eventually, the two will fuse into one massive elliptical galaxy. Historians still argue what this merged galaxy will be called. The most popular nickname, Milky, sounds like a breakfast cereal. Sure, but it fits. A hybrid, a beginning made from two endings. And what about the solar system? You wonder, will we still be there when the great merger begins? Maybe, maybe not. Our sun will likely be entering its final, bloated stages, swelling up into a red giant and making Earth somewhat less cozy. There's a chance our system could be flung outward in the chaos, maybe even exiled into intergalactic space. Just imagine a lonely little solar system tumbling through the void like a forgotten marble. And yet there's a strange piece to that idea. You float back a little, seeing both galaxies in the same view now. Andromeda on the left, Milky Way on the right. Two titans slowly falling toward each other. Not in war, not in hate, just in gravity. It's like watching the world's slowest hug. A fringe theory comes to mind. Some suggest that collisions like this might actually spark new life, not just stars, but perhaps new civilizations. As galaxies merge, gas clouds compress, forming new suns, new planets, new chances. In that chaos, in that reshuffling, something new is born. Maybe even someone like you, floating out here, wondering what came before. As you glide closer to Andromeda's leading edge, you feel the anticipation. The galaxy knows what's coming. It doesn't fear the Milky Way. It waits, ready to reshape, ready to grow. And you realize something quietly profound. Andromeda has been eating its neighbors for billions of years, not to destroy them, but to become something new. Every dwarf galaxy, every tidal stream, every stolen star, it's all part of a future identity still forming. The merger with the Milky Way won't be the end. It will be the next version. You drift back toward Andromeda now, the light growing warmer, the spiral arms wider. The stars seem to shimmer with purpose. They've been through this before, and they'll do it again. You are watching the universe evolve in real time, not in seconds, but in epochs. And somewhere in that vast destiny, you find your place. Small, quiet, but part of it. The galaxies keep moving. The story keeps unfolding. You drift now just above the visible edge of Andromeda's glowing arms, coasting into its outermost fringe, where light gives way to shadow and things become messy. But not empty, not at all. In fact, this is where Andromeda hides some of its strangest treasures, odd loops, twists, and clumps of stars that don't seem to belong. They defy symmetry, breaking the tidy spiral aesthetic that most galaxies wear like a badge of pride. You've entered the realm of tangled halos and hidden clues. The first thing you notice is a faint ring of stars that orbits outside the usual structure, tilted at a strange angle. It's not part of the disk, not part of any arm. It's like the ghost of a galaxy's ring, tossed into Andromeda, and now trapped in eternal orbit. Astronomers call this kind of structure a stellar shell or loop, and it's one of many circling Andromeda, like the rings of a tree that grew by swallowing other trees. One mainstream fact, Andromeda's halo contains more substructure than the Milky Way's. It's not a smooth field of faint stars. It's a jumbled patchwork of filaments, streams, and clouds, each one the remnant of a devoured galaxy. These are the fingerprints of cosmic cannibalism. You float past a particularly tight spiral of orphan stars now, like a scribble made by a child wielding gravity as a crayon. Here's where it gets fun. Some of these loops move in directions opposite to Andromeda's spin. That's a giant, shimmering clue. You're looking at retrograde orbits, a sign that the stars came from somewhere else entirely. When Andromeda swallowed its smaller neighbors, it didn't always do so neatly. Some galaxies came in at odd angles or speeds, and their stars now orbit like disoriented newcomers in a dance they were never taught. Historians still debate the origin of a particularly mysterious arc called the Giant Stellar Stream. You glide through part of it now, an elegant, faint ribbon stretching over 100 light years, curling behind Andromeda like a loose thread. Some believe it's the remnant of a single large galaxy torn to pieces around 2 billion years ago. Others argue it's the result of multiple mergers, overlapping and tangling together like vines in an ancient ruin. There's something poetic about it. You reach out a metaphorical hand, letting the light of these homeless stars flicker through your fingers. They don't orbit a core, they are the core, or at least what's left of it. An entire civilization, or more, might have once lived in this stream, long before gravity tore it from its spine and scattered it across the halo. A quirky bit of trivia for you. In 2020, astronomers discovered a series of feather-like substructures in Andromeda's outer regions. That's not a metaphor. They literally called them feathers. These wispy patterns curve outward from the disk and shimmer faintly in infrared. Their cores, likely smaller galaxies entering at shallow angles, carving graceful arcs before being digested. You follow one of these feather trails now, letting it lead you toward an unusual clump of matter, dim, slow spinning, not quite a galaxy, but more than a star cluster. It might be a dark matter satellite, an invisible mini halo whose stars were stripped but whose gravity lingers. Andromeda has many of these, like cosmic toothpicks left behind after a meal. They tell you what was eaten. Even when the plate looks clean, the dark matter here presses in again, not seen, but felt. You notice how stars seem to respond to things you can't detect. They curve, arc, loop around nothing, or rather, something you can't see. Dark matter doesn't clump the way stars do. It surrounds galaxies in massive halos, shaping their evolution, like scaffolding shapes a cathedral. You're floating through that scaffolding now. You can't see the beams, but you know they're there. Every loop and stream confirms it. And here's the strange thing. Despite being invisible, dark matter has built most of what you see. It decides how galaxies form, how they grow, even how they collide. It's the quiet architect of the universe, and Andromeda wears its work like a patchy, luminous coat. From your high perch now, looking down on the disk and its chaotic halo, you get a true sense of Andromeda's depth. It's not a flat spiral, it's a layered memory. The bright core is the newest chapter, the arms are the main narrative, and these twisted, tangled loops, they're the footnotes, the secrets. You wonder how many galaxies lie hidden in these remnants, not just stars, but names, histories, civilizations never known, now reduced to the gentle arcs of light above Andromeda's glow. You rise just a bit higher. Below you, the halo flickers with motion. Above you, the Milky Way shimmers in quiet anticipation. And in between them both, this vast angle of stars, each one a clue, a relic, a whisper. The galaxy keeps its secrets close, but tonight, it's letting you peek. You descend again, back toward the heart of Andromeda, not to its dark, swirling core, but to the places where light and structure speak most clearly. The spiral arms come into focus like gentle whirlpools of starlight, rotating with a grace that makes their true scale nearly impossible to grasp. And yet, you know what's coming. You've seen it from afar. Run your thoughts along the invisible thread of inevitability. The collision is coming. Andromeda and the Milky Way are on a cosmic date with destiny. But what does that really mean? Will galaxies scream? Will suns collide? Will Earth burst into flames? You float closer, gently slipping into a galactic simulation, not one of pixels and screens, but the living, breathing mathematical equivalent floating in your mind's eye. Think of it as a vision projected by physicists based on the raw gravity math of two spirals colliding in space. What happens next might surprise you. One mainstream fact: when galaxies merge, their stars almost never crash into one another. They're simply too far apart. A galaxy is like a swarm of bees, where each bee is the size of a marble, and the swarm is the size of Texas. You can slam two of those swarms together, and most bees will just sail on through, and so will we. In fact, when Andromeda and the Milky Way begin their gravitational waltz in 4 billion years, there's a good chance the Sun and whatever descendants it has will simply drift into a new orbit. Maybe closer to the center of the new galaxy, maybe farther out, maybe ejected entirely into deep space, which sounds dramatic. But hey, some people like a quiet neighborhood. You glide through a simulated future now. The first pass is violent, but not explosive, as Andromeda and the Milky Way draw near. Their mutual gravities distort one another. The spiral arms begin to bend, stretch, and tangle. Stars are flung out in long tails called tidal plumes, curving through intergalactic space like trails of glitter tossed into water. Historians still argue over the exact timing. Some models predict the first pass will occur in 4 billion years. Others say 4. Fine, either way, it won't be one quick smash and done. The galaxies will swing past each other, slow, then fall back together, drawn by their shared gravitational longing, like two lovers in a long-distance relationship, finally giving in. The second pass is more intense. By now, both galaxies have lost their beautiful spiral shapes. They've stretched into weird, lumpy blobs. You drift through their overlapping centers, where new stars are forming from compressed gas. A starburst event, they call it. Galaxies colliding may not create explosions, but they do create opportunity. The shockwaves ignite stellar nurseries like fireworks, birthing clusters of hot, bright, short-lived stars. A quirky visual appears: a pair of black holes, one from each galaxy, begin to spiral toward each other at the new galactic core. These are the supermassive ones. Remember, they don't just merge, they shutter space itself. As they collide, they send ripples of gravitational waves through the fabric of the cosmos. You wouldn't hear it. You wouldn't even feel it. But you'd know something had happened, like the universe had briefly exhaled. And when the dust settles, you're left with something new. Not a spiral galaxy anymore, but a giant elliptical rounder, slower spinning, quieter. Andromeda will have consumed not just the Milky Way's stars, but its momentum, its motion, its history. The galaxy that emerges won't be either one. It will be something else. Some astronomers call this final form Milkomeda, others go with Milkdromeda. You kind of wish they'd settled on something cooler. But regardless of name, it'll be huge, larger than either galaxy was alone, and stable. The chaos will fade, and what remains will orbit peacefully. For trillions of years, you drift upward in your mind's eye now, pulling away from the simulation, returning to your present view of Andromeda, still whole, still spiral, still waiting. But now you understand it differently. This isn't just a galaxy. It's a future not just for itself, but for us, because we are part of this merger too. Our solar system is a speck inside the Milky Way, and the Milky Way is heading into this embrace like a letter returning home. You realize, maybe for the first time, that this isn't destruction, it's evolution. Galaxies aren't dying, they're growing, becoming, blending. You float along the leading edge of Andromeda's disk now, watching the stars twinkle like stage lights waiting for the curtain to rise. There's no sound, no clock, just motion. You glance behind you, imagining the Milky Way approaching. You close your eyes not to sleep, not yet, but just to feel the scale of it all, the elegance, the patience. This is how the universe grows, not by haste, but by collision, not by explosion, but by merger. Andromeda is ready, and when the time comes, so will we. You're drifting now through a debris field, not of destruction, but of leftovers, old things, strange things. You're gliding between stars that no longer belong to anyone, pulled from their homes by gravity's slow mischief. This is where the neat diagrams fall apart. Welcome to the outskirts of order, where galaxies don't quite clean up after themselves. The stars here are rogue, not part of any clear stream, arm, or halo, just drifting, disconnected. You coast past one, a dull red dwarf, solitary and still. It's not dead, not even dying, but it has no orbit, no sun family, no community. It once belonged to a satellite galaxy, maybe one of Andromeda's ancient victims. Now, it just wanders. These are the alien sons of the galactic frontier. One mainstream fact: galaxy mergers eject stars, not by explosion, but by gravitational sling. It's called three-body interaction, a chaotic dance where one star gets launched outward while the others cozy up. Andromeda, with all its past mergers, has created countless such loners. Some are hurtling toward intergalactic space at speeds that ensure they'll never be captured again. But they're not alone, not really. Because where there are rogue stars, there are also rogue planets. This part always makes your mind tilt a little. Imagine a planet, roughly Earth-sized, hurtling through the darkness without a sun. No daylight, no orbit, just drifting endlessly. No sunrises, no seasons, just cold silence. Scientists believe that galaxies like Andromeda might contain billions of these worlds. In fact, they could outnumber planets that still orbit stars. You float near one now. It's not glowing. You only spot it because it briefly blocks the light from a distant star. That technique is called gravitational microlensing, and it's how astronomers spot invisible wanderers. You let your gaze follow it. No moons, no rings, no sunlight, just a rock, wrapped in ice and silence, tumbling through the dark. Historians still argue whether rogue planets can sustain life. Some theorize that deep beneath their frozen crusts, geothermal vents could create warm oceans, tiny pockets of habitability in an otherwise lifeless void. If so, life might thrive out here, completely detached from stars, entire ecosystems born in exile. It's a haunting thought. Creatures evolving in eternal night, never knowing what a sky looks like. You float onward, deeper into this chaos zone. Occasionally, you see strange alignments. 3 stars in a perfect triangle, a line of gas trailing behind a single star, a tight cluster with no visible center. These are scars, the gravitational wreckage of past interactions. They're not supposed to be here, but they are. A quirky tidbit: in 2012, astronomers discovered a superstar cluster near Andromeda's edge, massive, densely packed, and oddly isolated. It may be the last remnant of a galaxy long since torn apart. Think of it as the core that refused to scatter, still spinning, still defiant. You coast toward one such cluster now. It's tight, dense, hundreds of thousands of stars packed into a sphere only a few dozen light years across. It glows like a snow globe of fireflies. These stars are old, really old. Some are among the oldest in the universe. You wonder what they've seen. How many galaxies have they called home? How many times have they been flung out, only to regroup and survive? You're starting to see the galaxy differently, not as a clean spiral or a tidy structure, but as a living history, told in fragments. These rogue stars and clusters are like notes scrawled in the margins of a manuscript. Unofficial, maybe, but honest. vital, and somewhere in the distance, beyond even this chaotic zone, is the intergalactic medium thin gas, dust, and radiation, stretching between galaxies like the ocean between continents. Some of Andromeda's exiles have made it that far. A few may already be beyond rescue. You rise higher again, looking back at the galaxy now as a whole. Andromeda is still beautiful, still glowing, but now you see the trails, the faint, looping streams of stars curving outward like arms, still reaching for what was lost. And you see the gaps too, holes where stars once were, paths carved by collisions, like scars on the skin of space. And in between it all, drifting without orbit or anchor, are these alien wanderers, planets without suns, stars without homes. And yet even here, in the forgotten outskirts, there's a kind of peace, no explosions, no drama, just motion, just stars doing what they've always done. Moving forward, they may be lost, they may be nameless, but they're still part of the story. And so are you. The silence out here isn't lonely, it's pregnant. Something is happening. As you drift gently back toward the arms of Andromeda, you start to notice a change in the starlight, not in color or brightness, but in feeling. These aren't cold, ancient stars left behind in the wreckage. These are young, fresh, alive. You've entered one of Andromeda's many star-forming regions, nestled like glowing embers within the arms of the galaxy. From above, they look like little knots of color pink, blue, and gold woven into the swirling tapestry. But up close, they're enormous, clouds of hydrogen gas, stretching for hundreds of light years, folding and collapsing into stars before your eyes. One mainstream fact: galaxies like Andromeda are called spiral galaxies, not just because of their shape, but because their structure actively promotes star formation. The spiral arms aren't static. They're density waves that compress gas as they pass, triggering waves of stellar birth. You're watching one happen now. A great nebula blooms below you, like a rose unfolding. Inside it, tiny bursts of light flicker on baby stars, not yet steady, igniting in gas-thick cribs. You dip into one of these stellar nurseries, feeling the heat, not literally, of course, but with that inner sensor your dream self uses to feel warmth from light. It's cozy. In a nuclear furnace kind of way, you pause beside a protostar, no bigger than a Jupiter yet pulsing with internal pressure. It's not fusing hydrogen yet, but it will. The gravity is there. The collapse is happening. Soon it will burn, and around it might gather planets, moons, even life. Historians still debate how many of Andromeda's star-forming regions were triggered by mergers. Some believe that when Andromeda consumed smaller galaxies, it also pulled in their gas, compressing it in new pockets and setting off these stellar firestorms. Others argue the gas was always there, just waiting for the right shock to light it up. Either way, you're looking at something paradoxical: creation born from destruction. The deaths of other galaxies have become the seeds of stars yet unborn. It's cosmic recycling at its finest. Andromeda's most active star-forming region is called NGC 206. You're gliding over it now, a brilliant patch nestled in one of the galaxy's arms. It's about 4.00 light-years wide and contains some of the most massive stars in the entire local group. These giants don't live long, only a few million years, but they go out in spectacular fashion. That brings us to something oddly beautiful. Supernovae. The stars being born here today will someday explode, sending shockwaves through the surrounding gas, triggering more stars to form. You float through a supernova remnant now, a glowing sphere of expanding debris, like a flower that bloomed, screamed, and scattered its petals into the void, a quirky tidbit. Scientists have found evidence of hypervelocity stars in Andromeda, stars born in dense regions like this, then flung outward at incredible speeds, by gravitational interactions. Some might even escape the galaxy entirely. You wonder if any of them were born in places like this, only to be launched like cosmic cannonballs into the black. From this height, you notice something else: patterns in the starbirth. Clusters forming along curved lanes, following the spiral arms like stitches in a tapestry. The galactic arm isn't just a pretty swirl. It's a factory floor, pressing gas together with regular rhythm. You feel it now, the deep pulse of the galaxy, like a breath you hadn't noticed until you were standing in its chest. And it's not just massive stars being born. There are also solar analog stars, like our sun. Smaller and longer-lived, perfect for planetary systems. You drift over one now, so new. Its light still flickers slightly with accretion. Around it, a thin protoplanetary disk spins a cloud of dust and gas, just beginning to clump. Someday, this might become a system of planets, maybe even one with oceans, maybe even one with eyes looking up at the stars, wondering where they came from. You smile at the thought. In all this epic cosmic drama, black holes, collisions, tidal tales, here lies something intimate, quiet, the birth of a single sun, unseen, unremarkable to the galaxy as a whole, but infinite to whatever might one day live beneath its glow. You rise again, looking down at the glowing nurseries dotting Andromeda's arms. So much life, seeded by so much loss. It doesn't make the cannibalism less brutal, but it does make it meaningful. From the gas of old galaxies, something new has emerged and continues to emerge. And maybe that's the whole point. Galaxies don't just grow by swallowing others. They grow by transforming them, by turning ruin into light. You float upward, letting the glow fade, watching the spiral turn. You've seen its center, its victims, its exiles. Now you've seen its children, and somewhere, out there in the dark, you suspect one of those children might look a little like us. The spiral arms fall away beneath you, fading into softer shadows as you steer toward a strange zone where light behaves differently, not dimmer, not brighter, just stretched. And if you listen not with ears, but with that instinctual awareness your dream self carries, you can almost hear it, the faint, silent cry of gravity bending light, bending time, bending reality. You've arrived at the outermost edge of Andromeda's influence, where stars begin to act less like balls of fire and more like strands of sugar being pulled into cosmic taffy. This is where stars get stretched. It doesn't happen quickly, no dramatic tearing, just slow, inexorable elongation. You glide beside a small group of stars moving in tandem, but not quite orbiting. Their paths are warped, subtly off, each one tugged slightly out of alignment. These are tidally distorted stars, the result of gravitational interactions, especially between Andromeda and the smaller galaxies it consumes. One mainstream fact: when galaxies merge, stars near the edges often get caught in tidal forces so uneven that they stretch into long, thin structures. These are called tidal tails, and Andromeda has several. You're looking at one now, a whisper-thin trail of stars extending like smoke from a candle, tens of thousands of light-years long. You drift along its curve, tracing its shape like a finger running a long thread. Some of the stars here have been pulled into these formations over millions of years, slowly migrating from tight clusters into loose, stringy strands. They still burn, still move, but now as part of something much larger. They are no longer individuals. They are filaments in a galactic loom. Historians still argue over how permanent these stretched stars are. Some say they'll eventually collapse into new orbits, joining the host galaxy. Others believe they'll continue stretching, fading into intergalactic space. There are even models that suggest some tidal tails could form entirely new dwarf galaxies, coalescing like water droplets reforming after a splash. It's not just stars. You float past a gas streamer, a twisting ribbon of cold hydrogen trailing behind what used to be a satellite galaxy. It's not glowing, it's nearly invisible, but it reflects just enough starlight to shimmer like a trail of frost. Somewhere inside it, new stars may be forming, or maybe the gas will never find enough pressure to ignite. It will just drift, like spilled ink never soaked into a page. You pause beside a globular cluster, caught mid-stretch, half its stars still rounded, the other half peeling away like a handful of sand, slipping through an open palm. It's a slow-motion disintegration, the kind of thing that would be imperceptible from Earth. But here, up close, is tragic and elegant all at once. A fringe theory tickles the back of your mind. Some astrophysicists speculate that certain ultra-long tidal tails might connect galaxies across great distances, gravitational bridges forming through these stretched stellar highways. While unconfirmed, the idea is compelling. You imagine Andromeda once linking arms with some long-lost cousin through a tunnel of stars, now thinned to mist. One particularly bright star streaks across your path, now not because it's fast, but because it's elongated. It's part of a phenomenon known as tidal elongation, where stars orbit so close to a galactic core or another massive body that they're physically stretched by differential gravitational pull. It's subtle, only visible up close, but there it is, an ovoid shimmer instead of a perfect sphere. You pass by, watching the soft warp of light around it, the gentle tension in its glow. It's hard to shake the feeling that everything in this region is both breaking and forming, pulling apart and coming together. You're not in a place of endings. You're in a transition zone, a place where one galactic shape becomes another. It's not neat, it's not fast, but it's the honest, messy middle. You rise higher, tracing the arc of a long tidal tail that loops back toward Andromeda's disk. It reminds you of a comet's trail, only this one isn't ice and dust, but stars and gas and gravity. Each point of light here once orbited in stability. Now they're passengers on a rail made of distortion. And yet, there's beauty here, a kind of resilience. Even as they stretch, even as they pull apart, these stars remain part of something. They are not lost, they are becoming. You hover a moment longer, watching the slow, balletic drift of it all. No rush, no drama, just light, pulled thin across time. And it hits you. Galaxies don't break. They bend, they reshape, they reform. Andromeda is not falling apart. It's finding its next shape. And every star stretched along these tails is a brushstroke in that masterpiece. You leave the tangled filaments behind, letting the warps and curves of stretched stars recede into the dark. There's something still ahead, something bigger, quieter, but more profound. You're approaching the event that every single tail up to now has been building toward, the great cosmic exhale. You're about to witness the final galactic merger, not in a flash, not in a bang, but in motion slow, stately, gravitational choreography that unfolds over billions of years. Andromeda and the Milky Way, each with their spiral arms outstretched, are spiraling toward one another. This is it, the great galactic embrace. You float high above the scene. There's no top or bottom in space, but from this angle, you see both galaxies clearly. Andromeda tilts gently toward you, arms wide. The Milky Way rises to meet it. They're not slamming together. They're docking, like two great ships in a cosmic harbor. You pause there, breathless, metaphorically speaking, as the galaxies pass through each other for the first time. That's right through, not into. The first encounter won't destroy them. Their massive halos overlap like the misty edges of fog banks. The stars, most of them don't touch, but gravity does, hard. One mainstream fact: the first pass between the Milky Way and Andromeda will stretch both galaxies out of shape. flinging spiral arms into long tendrils, igniting starbursts, and flinging hundreds of millions of stars into wild, elliptical orbits. The second pass will be closer, tighter, and the third, that's when the cores spiral in and merge completely. From your vantage point, it's like watching time-lapse footage of continents crashing into each other, but slowed down to the tempo of eons. The galaxies begin to deform, losing their spiral identities, fusing into an enormous, glowing cloud. The neat geometry of arms and bars dissolves into a hazy swirl. Chaos gives way to something rounder, quieter. You're witnessing the birth of a new galaxy. Historians still debate what this final form will look like. Most agree it will be an elliptical galaxy, shaped like a glowing rugby ball, its stars orbiting in randomized directions. No more spiral structure, no more arms, but not featureless, just more settled, as if the galaxy has finished its wild youth and is ready to become something slower, more reflective. Astronomers think this merged galaxy could be 10 times the mass of either original. The Milky Way brought its black hole. Andromeda brought its own. Now they spiral together at the heart of this new entity, their orbits shrinking as they radiate gravitational waves. You float near the center, watching from a safe theoretical distance. Eventually, the two black holes merge, not with a visible boom, but with a tremor that ripples through space-time itself. A gravitational wave echoes outward, unnoticed by the stars around it, but detectable across the cosmos by machines and minds still yet to be born. A fringe theory whispers to you here. Some scientists believe that such black hole mergers might reignite galactic centers, turning dormant cores into blazing quasars. For a time, the newborn galaxy might glow with furious light, outshining entire clusters, until its gas is exhausted and silence returns. You drift outward now, letting the newborn galaxy, call it Milkomeda, if you like, settle into view. It pulses gently, a great glowing egg in the quiet dark. Its edges are soft, its motion calm. The violence of merger has passed. Now comes the long era of stillness. This is the galaxy's middle age. It will persist for trillions of years. The bright blue stars formed in the chaos will fade quickly, burning out in a few million years. The red dwarf, small, steady, stubborn, will burn on and on and on, while other galaxies drift apart, lost to the accelerating expansion of space. Milkomeda will be a cosmic island, alone and complete. You wonder where Earth is, where we are. The answer is simple. We're either long gone or flung into some far orbit within this merged mass, our planetary memory reduced to one more flickering point of light among billions. And still, you feel peace. Galaxies are not static things. They're not objects. They're stories slow burning, billion-year-long stories told in starlight. What you've just seen is not the end of Andromeda. It's not the end of the Milky Way. It's the next chapter in a book the universe has no intention of finishing. You float backward one last time, letting the great elliptical galaxy fill your field of view. It's not a spiral anymore. It's not blue and structured, but it's alive. In the only way galaxies know how to be glowing, spinning, whispering gravity to everything it holds. And somewhere, far from its quiet center, a lone star drifts. Maybe it's the sun. Maybe it's not. Maybe there's a planet. Maybe there's a listener. Maybe there's you. You linger at the edge of the newborn galaxy, hovering in the great hush that follows transformation. Milkomeda, yes, let's call it that. The now no longer whirls with the graceful arms of a spiral. Instead, it pulses softly, a giant elliptical cloud of memory and light, drifting through a universe that's growing darker by the day. The stars here move in all directions, no longer locked in tidy lanes. They follow paths that intersect, overlap, weave a murmuration of light shaped by invisible hands. It's quieter now, slower, older, but not dead. You drift inward, gently threading your way through the new core, its vast and dense home to trillions of stars, globular clusters, and that enormous merged black hole that once belonged to both Andromeda and the Milky Way. You can't see it, of course, but you know it's there. The stars dance faster here, drawn to a center that swallows time itself. There's no chaos anymore, no more dramatic stretching, no wild flinging of arms. The galaxy has found its shape. It has digested its history. Everything that was Milky Way, Andromeda, Triangulum, a dozen others is now here, tucked inside this single glowing hole. One mainstream fact: galaxies like this are destinies. Astronomers believe most large spirals eventually become ellipticals through mergers and the gradual depletion of star-forming gas. Spirals are the youth, ellipticals are the long, meditative afterward. But even now, there are sparks of new beginnings. You float past a nebula, a pocket of gas somehow spared from the great consumption. Within it, stars are forming still. Even here, amid the calm, new lights flicker on. The universe isn't finished yet. You move through one final tidal stream, faint, worn, nearly erased. It's barely a trace now, just a pale swirl of stars spiraling lazily through the halo. You suspect it was once Triangulum, long ago devoured and forgotten by all but gravity. You give it a nod. Every star has a name, even if no one remembers it. And beyond Milkomeda, nothing visible. The expansion of the universe has carried other galaxies so far away that their light no longer reaches us. The cosmos is growing colder, emptier, but not this place. This place remains. A fringe idea drifts through your thoughts. Some physicists suggest that after 1 trillion years, all distant galaxies will have vanished from our horizon. The universe will seem like Milkomeda is all that ever existed. The descendants of stars might gaze into the night and see only their own galaxy, unaware of the vast web that once surrounded them. You imagine them, quiet civilizations tucked into corners of this eternal home, unaware they are the remnants of a dozen galactic histories, that their star is part Andromeda, part Milky Way, part ancient gas from collisions long past. Their night sky will be filled with stars, and only stars. No hint of the universe that once boiled with motion. And yet, isn't that peaceful? You rise now, slowly, letting the final gravity well recede beneath you. Milkomeda turns quietly, its shape soft, its light steady. There's no rush here, no urgency, just stillness. The tale of Andromeda is over, but not gone. It has been folded into something greater. Its arms, its clusters, its chaos all remembered, all repurposed, nothing wasted. You drift farther, letting the hum of starlight soften into silence. You think of rogue planets, feathered streams, black holes and stretched stars. You think of mergers and memories, of collisions that weren't endings, of loss that became light. And somewhere far below, a small star flickers. Around it, perhaps, a quiet planet turns. Perhaps on it, someone looks up and wonders where it all began. You smile, because now, you know. Let yourself drift now further still, beyond light, beyond sound. The story is finished, but the motion continues. The galaxy below you spins on, slow and soft, its stars dimming ever so gently with each passing billion years. You no longer float, you simply are. A silent observer tucked into the fabric of something far greater than any one life. One planet, one night. The stars whisper their final thoughts in long, slow pulses. Some are already extinguished. Others have yet to be born. All of them are held in the gentle arms of gravity, that ancient force that sculpts and carries, embraces and dissolves. No alarms ring here, no sudden jolts, only breath, the kind you take when you're not thinking about breathing, the kind you take when you're safe, the kind you take when you're on the edge of sleep. Let the image blur. Let the spiral fade. You are no longer watching Andromeda's story. You're folded inside it. The dark is not frightening here. It's soft, vast, and complete. So breathe and let go. You've drifted with galaxies. You've watched stars stretch, black holes kiss, light bend. You felt the slow rhythm of a cosmos that always continues. And now it's time for rest. May your thoughts dissolve like starlight into space. May your dreams glide gentle as halos. May your nights stretch long and quiet. Sleep well, little traveler. The universe will still be here in the morning.